Right now, as you're watching this, a Cascade Range stratovolcano that is directly visible from the windows of downtown Portland, Oregon, to mountain 2.5 million people can see from their homes and workplaces, is producing a seismic swarm that its scientists have not observed in the modern monitoring era. The volcano is Mount Hood, not Mount Rainier, whose July emergency dominated the country's Cascade coverage, not Mount St. Helens, whose 1980 eruption remains the defining American volcanic memory. Mount Hood, the perfect white pyramid on Oregon's northern horizon, the state's tallest peak at 3,429 meters, the mountain whose summit fumaroles have quietly steamed above the Timberline Lodge ski resort for the entire lifetime of the folk, everyone reading this. And on the USGS's National Volcanic Threat Assessment, Mount Hood ranks in the very high threat category, one of only 18 American volcanoes at that tier, for one specific and irreducible reason. No other American volcano combines its eruptive style, its lahar geography, and the size of the metropolitan population immediately downstream. On August 13, 2026, the USGS Cascades Volcano Observatory raised Mount Hood's alert level from normal to advisory. The Pacific Northwest Seismic Network had recorded, over 96 hours, a swarm of more than 940 small to moderate earthquakes beneath the summit and upper south flank, the largest reaching magnitude 3.4-, felt by residents of Government Camp and hikers at Timberline. GPS instruments have documented a modest but distinct inflationary signal, a few centimeters of ground uplift concentrated in the summit region. Fumarolic activity at Crater Rock, the persistent steam vents just south of the true summit, has intensified with visibly larger plumes reported by climbers. Over the past 2 weeks, in elevated hydrogen sulfide readings from CVO's gas sensors, every one of those signals, individually, is within the range of past Hood activity. The combination arriving simultaneously in one 4-day window is what raised the alert level. And the specific reason Mount Hood earns the phrase "most dangerous" in this video's title is not that it will erupt tomorrow, and not that it produces the largest eruptions in the Cascades. It is that when it does erupt, and it has, in ways preserved in Native American oral history and in geological deposits still visible on the mountain, the lahar pathways run directly through the Sandy River Valley, into the Columbia River, past the town of Sandy, past Troutdale, and into the eastern edge of the Portland metropolitan area itself. No other very high-threat American volcano sits above a metro of 2.5 million people, at a distance measured in tens of kilometers, with river valleys that connect it to that metro, like arteries. Today we break down exactly what Mount Hood is and why its eruptive style matters, what the mountain did between roughly 1,781 and 1,793 in the eruption, preserved in tribal memory as a fire in the sky, why the summit's persistent fumaroles carry a hazard type that no monitoring on Earth can reliably forecast, the two most instructive volcanic responses of the modern era. One in Indonesia, where escalating warnings saved perhaps 20,000 lives. One in Japan, where a mountain gave no warning and killed 63 hikers on a peak autumn day. And what a working preparation system for a mountain above a major American city actually looks like in practice. No guessing, no dramatizing, just the volcanology, the record, and the real stakes. Drop a comment right now. Are you in the Portland metropolitan area, in Sandy, in Gresham, in Hood River, in Government Camp, or anywhere in the shadow of Mount Hood? Have you climbed the mountain, skied Timberline, or hiked to Crater Rock and looked into the steaming fumaroles? Tell me your community, and tell me honestly whether you have ever thought of Hood as a volcanic hazard rather than a scenery. And for everyone else, had you ever heard that Mount Hood erupted less than 250 years ago, within the lifetimes of people whose grandchildren still live in Oregon today, because the gap between how Portland sees its mountain and what the mountain actually is precisely why this video exists. Subscribe right now if you want. Every USGS Cascades Volcano Observatory update, every Mount Hood alert change, and every significant American volcanic development covered as it happens. Completely free. A thumbs up puts this in front of the Portland area residents who need to understand what their skyline mountain is doing right now. Let us go for 6,000 likes. Now let us meet Mount Hood on its own terms. Mount Hood is a stratovolcano, the same fundamental type as St. Helens, Rainier, Pinatubo, or Fuji. Stratovolcanoes are built layer by layer over hundreds of thousands of years by alternating eruptions of viscous lava, pyroclastic flows, and ashfall, Their magma is intermediate in composition andesite to dacite, which means it is stickier and more gas-rich than Hawaiian basalt, which means it does not flow easily, which means it accumulates pressure as it rises and then releases that pressure explosively. Stratovolcanos are the volcanoes people picture when they think about volcanic eruptions. Steep-sided cones with dramatic craters that produce catastrophic explosive events. Hood is that class of volcano. The mountain's eruptive history is dominated by what geologists call dome-building eruptions. Rather than a single vast explosive blast like St. Helens 1980, Hood tends to grow a viscous lava dome at its summit or upper flank, and that dome, brittle, unstable, gas-charged, repeatedly collapses in pyroclastic density currents and generates lahars as the flows melt summit snow and ice. The mountain has produced two major eruptive episodes in the last 2,000 years. The Timberline eruptive period, roughly 1,500 years ago, built the current summit crater and produced lahars that traveled 100 kilometers down the Sandy River to the Columbia. The Old Maid eruptive period, dated to between roughly 1,781 and 1793, deposited pumice and produced pyroclastic flows and lahars that flowed down the Sandy River drainage and left deposits still visible today at the base of the mountain, including the pyroclastic deposits. Directly beneath Timberline Lodge, which sits on Old Maid era material. The Old Maid eruption is genuinely recent in geological terms, less than 250 years old. Lewis and Clark, descending the Columbia River in 1805, encountered Mount Hood's Sandy River Delta and named it Quicksand River because of the enormous volume of unconsolidated volcanic sediment that Old Maid had deposited and that the Sandy was still carrying to the Columbia in 1805. That sediment came from the mountain. From an eruption that had ended barely 12 years before, Lewis and Clark saw its results. Native American oral histories of the Wasco, Multnomah, and other Columbia River peoples preserve accounts of Mount Hood in eruption of the mountain smoking, of fire visible at night, of the rivers running with a strange color. This is not ancient history. Portland, Oregon was founded in 1845, just 52 years after Hood's most recent eruptive period. The Old Maid eruption is a specific event that scientists model when they ask what a modern Hood eruption would look like, and that scenario is dominated not by explosive ashfall over Portland, though ash would reach the city, but by lahars in the Sandy River Valley. The Sandy River drains Mount Hood's western and northwestern flanks. It runs approximately 90 kilometers from the mountain's base to its confluence with the Columbia River at Troutdale, on the eastern edge of the Portland metropolitan area. The Sandy passes through the town of Sandy, population approximately 12,000, the community of Boring, and drains a broad valley of farms, ex-urban neighborhoods, and highway corridors. USGS lahar hazard mapping shows that past Hood lahars, from both the Timberline and Old Maid periods, inundated the Sandy River Valley floor to depths of meters, in some places tens of meters, and, in the largest events, reached all the way to the Columbia River. A repeat of an Old Maid scale lahar today would follow the same pathways, and those pathways now include US Highway 26, the main road connecting Portland to Hood ski resorts, carrying millions of vehicle trips annually, and Interstate 84 at the Columbia Confluence, one of the most important east-west freight corridors in the western United States. The White River Valley on Hood's east side and the Hood River Valley on the north side face their own lahar risks. The town of Hood River, population approximately 8,500, sits at the mouth of the Hood River, where it meets the Columbia, and past lahars have reached that confluence, but it is the Sandy River corridor toward Portland that carries the largest exposed population, the most valuable infrastructure, and the shortest transit time between a summit event and its arrival. At inhabited areas. Now, the specific hazard that no monitoring system can fully forecast, and that makes Hood's active fumaroles at crater rock uniquely concerning, even without any large-scale eruption. Phreatic explosions, steam-driven blasts powered by the sudden flashing of hydrothermal water to steam, do not require any fresh magma to reach the surface. They occur when heat from the volcanic system pressurizes water in the shallow subsurface until a seal fails, or a fracture opens, and the water expands its volume by more than 1,000 times in seconds, hurling rock and steam explosively outward. These events are typically small in volcanic terms. They are also, in populated or trafficked areas, potential mass casualty events, because they can occur with essentially no useful precursor, and because they happen exactly where hydrothermal activity is, visible at the surface, which is exactly where tourists, climbers, and workers tend to be. Mount Hood's crater rock area has active fumaroles year-round. Climbers on the standard south side ascent route pass within 100 meters of them. The Palmer Glacier area, popular for summer skiing, sits on the upper south flank. Timberline Lodge hosts more than 1 million visitor days annually. And a phreatic event at Crater Rock, the exact category of hazard the current fumarolic intensification most directly signals, is the class of event no volcano observatory. Anywhere on Earth can reliably warn a climber about in the minutes before it occurs, which brings us to the contrast that gives this video its most important lesson. On October 25th, 2010, Indonesia's Mount Merapi, a stratovolcano rising above the densely populated Yogyakarta region, home to more than 3 million people within reach of its worst-case hazards, entered a major eruptive phase. Under the leadership of Chief Volcanologist Surono, Indonesia's Center for Volcanology and Geological Hazard Mitigation escalated the alert level in stages and expanded the exclusion zone from 10 kilometers to 15, and then, in the eruption's most intense phase in early November, to 20 kilometers minus unprecedented expansion that displaced hundreds of thousands of people from their homes and farms. Surono's call to widen the zone was scientifically contested and politically costly. It was also correct. On November 5th, Merapi produced its largest eruption in over a century, to pyroclastic density currents that swept exactly the terrain the expanded zone had cleared. The death toll was approximately 350 people, most of them individuals who had returned to their homes inside the exclusion zone against orders, and a much smaller number who were caught unexpectedly. Estimates of the deaths prevented by the expanded evacuation, deaths that would have occurred if the zone had remained at 10 kilometers or even 15 range, into the tens of thousands. The Merapi 2010 response is now taught in every serious volcanology program as an example of what escalating warnings, executed with institutional courage, can achieve. Now look at Japan on September 27, 2014. Mount Ontake, an active stratovolcano popular with hikers in the Japanese Alps, had shown some low-level unrest earlier in the month, but no signals sufficient to trigger official warnings or trail closures. At 11:52 in the morning, on a clear autumn Saturday at peak hiking season, with hundreds of hikers on and near the summit, Ontake produced a sudden, phreatic explosion. There was no meaningful precursor. There was no warning. Hikers at and near the summit had no time to descend. 63 people died, most from impacts of ejected rocks and from ash and asphyxiation. It was Japan's deadliest volcanic disaster since 1926. And the post-event scientific reviews reached the honest and difficult conclusion: this class of event is not currently forecastable in a way that gives useful warning time. Merapi and Ontake are the two poles of what modern volcano preparation can and cannot do. Merapi 2010 shows that when a volcano gives escalating precursors and institutions are willing to act decisively, mass casualties are preventable at scales that make an entire population's inconvenience morally trivial by comparison. Ontake 2014 shows that some volcanic hazards, specifically phreatic events at active fumarolic systems, arrive without the precursors that make Merapi-style responses possible, and that human presence in those specific zones during periods of any elevated activity is a category of risk that no monitoring can fully offset. Mount Hood's current signals include both the Merapi category and the Ontake category. The summit seismicity and inflation are the kind of signal that Merapi-style escalating monitoring is designed to catch. And the CBO's advisory level declaration is a version of that first escalation step. But the intensifying fumarolic activity at Crater Rock is a marker of exactly the Ontake-style shallow hydrothermal system that can produce phreatic events with no meaningful warning. The most defensible response, and the one CVO and the Forest Service are executing this week, is to combine continued instrumented monitoring for magmatic escalation with an immediate reduction of human presence in the summit fumarolic zone, closures of climbing routes near Crater Rock, updated guidance for timberline operations, and clear public communication about which forms of hood recreation carry which level of new risk. Let us be direct about the practical message, because information without action is just anxiety. If you live in the Sandy River corridor, Sandy, Boring, Gresham, Troutdale, the practical actions are specific. Familiarize yourself with USGS lahar hazard maps for the Sandy River. They are publicly available through CVO's website. Now, whether your home, workplace, or your children's school sits within a lahar-inundation zone, if you are within one, plan a walking route to safe elevation, because a lahar triggering event at the summit could reach the upper Sandy Valley within tens of minutes to an hour, depending on the specific scenario, and vehicular evacuation on the two-lane roads of the corridor would gridlock rapidly. For Portland Metro residents outside the immediate Sandy corridor, your primary hood eruption exposure is ashfall, which under prevailing westerly winds would most often be carried away from Portland toward the east. But wind can shift, have N95 or better masks available for household use during ash events. Ash is not merely an inconvenience. Inhaled at concentration, it is a serious respiratory hazard, and it fouls engines, HVAC systems, and water supplies. If you are climbing, skiing, or hiking on Mount Hood in the coming weeks and months, check CVO's alert status and any closures issued by the Mount Hood National Forest before you go. Do not approach fumarolic areas at Crater Rock during any period of elevated volcanic activity. The Ontake lesson is that these events give no warning. The presence in the zone is the exposure. Absence from the zone is the only reliable mitigation. For the state of Oregon and its emergency management agencies, the August 13th advisory is the moment to refresh the multi-county lahar response plans, verify the wireless emergency alert coverage for the Sandy corridor, and communicate proactively with Sandy, Gresham, Troutdale, and Hood River jurisdictions about what specific escalation would trigger what specific public action. The window of advisory level unrest is exactly when the coordination should be exercised, not after watch or warning has been declared. Final thought. Mount Hood is the mountain on the Oregon license plate. It is the scenery from thousands of Portland office windows, the destination of 1 million skiers a year, the perfect symmetrical peak that appears on wine labels and postcards. It is also an active stratovolcano that erupted within the lifetime of the great-great-grandparents of some people watching this video, whose most recent eruptive period deposited the ground beneath Timberline Lodge, whose lahars have reached the Columbia River in the past and would reach it again, and whose summit fumaroles have been quietly telling scientists for 100 years that the system underneath is still warm. Unpressurized. For 233 years since the Old Maid eruption ended, Mount Hood has been quiet. Portland has grown from a non-existent settlement to a metropolitan area of 2.5 million people directly downstream of that mountain. In that time, the buildings, the highways, the schools, the airport, and the freight corridors that make modern Portland possible have all been built during Hood's silence, an interval that seemed permanent because no one alive today has watched it end. The August 13, 2026 seismic swarm may resolve without escalation. Most volcanic swarms do, or it may be the first phase of a reawakening on the timescale of weeks to months. And Portland's Hood preparedness infrastructure, built specifically for exactly this scenario over the past 4 decades, will be tested in real time. Merapi 2010 showed what monitoring and courageous institutional action can prevent when a stratovolcano wakes up. Ontake 2014 showed the specific residual hazard that even a fully monitored volcano can produce without warning. Mount Hood sits above one American city with the potential to demand both lessons at once. Look at your skyline the next time you can see the mountain. Ask yourself whether the last generation of Portland's growth built a city that is ready for the mountain it looked at every day, and then act in your household and your community on the answer. We will track every Cascade Volcano Observatory update, every Mount Hood alert change, and every development from this system as it unfolds. Subscribe so you do not miss it, and leave that comment, your community in the Portland Metro, and whether today is the first time you have thought of Hood as anything other than scenery, because closing that gap is the specific job this video exists to do. 6,000 likes. Let us go.